Welcome everyone. I'm sure everyone here, I haven't seen a lot of guests in the audience for a long time. For those that know me, my name is Shib. Been one of the first people to develop Bittensor way back in the day with Const, and been on it since. Const is otherwise a tad indisposed today, so I'll be covering for him. And I've got with me the awesome Macrocosmos team who are going to be presenting their subnets and what they've been up to. And it's going to be nice and chill and fun, and really excited to be back up here. Good to see all these beautiful profile pictures.
Thanks, Shib. Should we take it on, I guess?
Yeah, let's take it on. I'll be here. I'll be emceeing, and just interrupting you here and there with some questions.
We have slides, guys. We're like old school from that side, so apologies for them, but you will get to see our beautiful graphics team and some of the stuff they do. So for those of you who don't know me, I'm Fox or Will. I'm CEO at Macrocosmos.
I'm here as well on Will's mic. This is Crooks, or Stefan in real life. Hey, everyone.
And you've got Mike here, the CFO as well.
So I guess look, we have a bit of a whirlwind tour to take you guys through. And, Shib's going to be our delightful MC and probably drop some bars in the middle just to mix it up a little bit. But we have sort of like three main topics we want to cover. One is the last time we sort of came in front of you guys, we were talking about one subnet, Subnet 9. And that was super exciting. But many of you, I guess, have noticed that we have 5 subnets. And so today's presentation is very much going to be like about what we're doing with those 5 subnets, how we've been working on them, what's improving on them, and also what's next for them. And we're also going to give you a little bit more information, a little bit of a teaser about why 5 and why they hang together and sort of the purpose and a bit of the strategy behind what we're doing. So we're probably going to talk for like 15, 20 minutes. Stick your hand up. Shib's going to break us up, but then we can take any questions and content you have. But look, without further ado, we formed in about April of this year. And for those of you who don't know, Stefan was latterly the CTO of the foundation. And we sort of broke out from the foundation as a carve out because we wanted to do something on top of Bittensor as opposed to building the core protocol. And my favorite thing about this slide is it's already out of date. Today, we're about 27, 28 people. We comprise now 16 nationalities, over 22 languages. And we have 7 PhDs. We found another one. We've always sort of looked at our position as trying to be like a decentralized AI lab on top of Bittensor, trying to do a lot of the complex work around how do we fit these puzzle pieces together to make them competitive. And we think Bittensor is the best place to do that. And that's why we're excited to be here. I guess the subnets we run will take a little bit of a story through. But one of the things we wanted to do, I guess, was talk about that there's a lot of speculation in Bittensor about price, which is sometimes the wrong way of looking at it. But we've been doing a lot of market analysis recently on what we think the opportunities around decentralized AI are. And this is more of a top-down picture, but some of these industry reports around 15.7 trillion of value to the economy, 256 billion a year by 2023 in services and value, and the trough of disillusionment around sort of AI, all factor up into these huge numbers of valuations you're seeing for firms like OpenAI. So I think 750 billion was the recent mooted value. And look, I think everyone's kind of here and part of this community because they see the immense opportunity posed by this AI transformation. One of the things we've been trying to look at is what are the sectors we think are really appropriate for decentralized solutions and AI solutions, and how can we start to target them? So we did a bit of work going back through a broader market analysis of different sectors, read a lot of industry reports, and sort of looked at what sectors we felt we could target with the sort of solutions we're putting together and building. And we also looked at the sort of problem space of what pieces would we need to compete in this sector. So technology, kind of self-explanatory, I think we all understand that. But when we were looking at sort of markets like energy and systems optimization and materials flows, we started to think we were going to need to do everything from training foundation models to doing quite discrete intelligence tasks to acquiring data. When we looked at markets like media and telecoms, where we feel a lot of the work on Subnet 13, which we'll talk about later, is relevant, we felt that we needed certain pieces that we couldn't do with one subnet. And similarly with, I guess, professional services, there is this sort of constellation effect of you need lots and lots of pieces of the AI process to be really effective in this space. And in Bittensor, ultimately, the network needs lots of these commodities to be super valuable. And we sort of saw a lot of harmony between building more than one of them. I guess the final point we looked at, and perhaps this explains a little bit of our purpose behind protein folding originally, was we've always looked at Bittensor as a really interesting place to do high-grade scientific type research and simulation. And, from an economics perspective, what that means is doing things like protein folding starts to unlock the healthcare, the pharmaceuticals markets, and these things, which, at a sort of pessimistic value, looks at a circa 8 billion market. So, some of the work we're doing is very much trying to expand the total addressable market to Bittensor as much as, building the pieces of the puzzle to attack those things in the chain. So look, a quick top line intro into, I guess, which subnets we run and what they do. Then I'm going to hand over to Crux to drop some knowledge on benchmarks and other stuff that we've been doing. On the far left, and this is sort of not in a numerical way, but in a logical sequence, Subnet 13, our data universe subnet, as of, I think, last week, passed 1.8 billion rows of data, which makes it the biggest social media data set in the world. So, a little bit of a flex there, but it's very much a subnet built around acquiring data at scale. And we're going to talk a lot more about what we're planning to do with that in the next few months shortly. Subnet 9 pre-training, I think most of you know about that. We spoke about it a lot on the previous novel search, but training of foundational models. Fine-tuning is a subnet we've been working on with Talverse in collaboration about fine-tuning, sort of building on some of the work done by Noose. And Subnet 1 is very much Apex intelligence and trying to create task-specific intelligence. And on today, we're also going to be talking about how we've been doing some technical asymmetry work. And Steph's going to talk a bit more about that in excitement. And finally, protein folding. And protein folding is, I think, in a lot of ways, some people's favorite subnet that we do, because I think it's kind of certainly for a lot of people, it's the first idea they had when they heard about this big decentralized computer in Bittensor is folding at home. And we've got some exciting stuff to share on that today as well. So I'm going to hang over to Steph, and he's going to talk a little bit more about, I guess, what's going on behind the scenes on each of these subnets on a technical level. So Steph, over to you.
Yeah. So look, in order to get these commodities out of scale, I think everyone that has tried to build a subnet has now learned, most likely the hard way, that it's incredibly hard to get subnets to work optimally. A big part of that as well is just making sure that they are getting smarter over time. They don't stagnate. They're really driving innovation through incentivizing the miners to sort of maximize their effectiveness. So, the climate right now in Bittensor is very much one which has embraced the sort of traditional AI benchmarks that the research, very recognizable measures of capabilities and intelligence. So we've got a slide here which celebrates some of the KPIs and benchmark performance across all of our subnets from left to right. So I'll just double click on a few that I think are the most important, but at a very high level, all of our subnets are getting better. They're actually improving constantly, which is exactly what we like to see, which gives us the confidence to make the next step and actually open these things up as services and products. So Subnet 1, we have been quietly benchmarking it on a couple of different interesting benchmarks, one of which is MMLU. It's a well-recognized benchmark which our LLMs are often weighed up against. What you can see in the blue curve is basically the performance of Subnet 1 on MMLU since we quietly and stealthily started sort of trickling questions through the network for the last couple of weeks. There's a couple reference lines that you'll see there, and I actually have a slide on this afterwards. But the main thing is we've actually exceeded the validator's intelligence, which you can see here on the right. The green line is actually the base validator intelligence. The miners have actually gone above and beyond that. This is a really promising sign for us. This means that the miners are not overfitted to contrived tasks, as some people may have been concerned. But in fact, what's happened is they're much more capable of using the web as a resource to enhance their answers. And that's measured by something like a benchmark here. We actually created our own version of MMLU, which we call the multiple choice task. And it's designed to be very similar in nature, except, of course, it has the benefit that it's constantly creating new questions that have never been seen before in real time. So this has the effect of avoiding the unwanted situation where miners have an opportunity to memorize the questions in advance. So we're really proud of the results that we're getting on that as well, where sort of the network's been hovering around 80% on our multiple choice task, which we think is a little bit harder than MMLU. We're actually going to do a detailed analysis of sort of how equivalent these two tasks are in an analysis that's upcoming. But we're really proud of that.
Quick thing, Stefan. Sorry, you're kind of blasting through. So I have a quick question for you. You had mentioned using MMLU, and you have a modified version of MMLU as well. Maybe it might be good to explain to some folks why you picked MMLU. Why is that a good benchmark compared to, say, I don't know, Helm or something else?
Sure. So I guess I could answer that in two parts. For one thing, one of the most difficult thing about LLM-based subnets is measuring quality of answers because it's a string of text. It's very easy to get lost in sort of the, well, was this word choice better than that word choice? Where are the facts hidden in the answer? And you kind of get lost quite quickly in subjectivity. Benchmarks are designed to simplify the process of measuring intelligence because they're typically structured like multiple choice questions. So this basically means there's no ambiguity. You choose the right option or you don't. So the scoring part is much more straightforward and reliable. The reason why MMLU is favored is because it's expert curated. So PhDs, world experts sat down and they came up with what they felt were a really testing suite of questions across something like 50 different categories of knowledge. So it's a very expansive and a very complete measure of intelligence. And that's why it's become so popular. Does that answer the question for you, Shiv?
That was excellent.
Awesome.
Thank you. I guess one follow-up, if that's cool, is have you guys started looking into benchmarking, say, for example, all of Subnet 1 and comparing it to what the current state of the art is at today?
Absolutely. Yeah. So actually, the plot on the top right, that is the average of Subnet 1. That is not the smartest miner on Subnet 1. So if we were to actually preferentially sample just the smartest, it would be considerably higher than this. Awesome. But yeah, absolutely. The natural thing to do next is to look at how we relate to the current frontier models like the GPT-O previews and so on. That's definitely something we're interested in doing. Yes.
Perfect. Sounds good. Thank you.
Cheers, man. Look, so while I'm on Subnet 1, some other important parts of the development of Subnet 1 is actually we're leaning a little bit more into guaranteeing reproducibility now. So less of the miners being able to operate in the shadows and more us bringing them to the surface through tasks such as the inference task, which is a deterministic inference task. And the goal here is to build sort of very stable building blocks that we can start really expanding into enhanced inference, as we call it, which is ensemble approaches, novel forms of reasoning chains, reflection modalities. And we think that in order to get there first, we can't just compound too many layers of abstraction. So we've been very carefully sort of deconstructing what we think the necessary steps are to get world-class performance in inference. And we're really excited to start showing you guys that stuff in a white paper that we're working on. So I'll skip ahead because we've got a lot of material to get through. Will, you want to jump on?
I think what's really exciting about one is we seem to have found a way to break the validator being the bounding intelligence, which has always been the sort of throttle that sat on non-deterministic inference subnet designs. So we've looked at a lot of methods for how we sort of reinforce this and accelerate this, but also if you start to put different models in as the validator bound, and there's a load of different conversations we could have about that, we believe we can still force miners to increment their improvement on top of that, which is what we're really excited about and why we think this is really compelling. But Steph, back over to you.
Cool. Well, yeah, I've got a load more to get through, so I'll be selective with what I double click on here. In Subnet 9, we've now introduced benchmarks in our dashboard so that everyone can see how the top models compare to current state of the art models in that class, which we think is a really important sanity check. So we have a reference point for all of the models that we produce. On Subnet 13, Will already mentioned we are seriously hoovering up data at scale right now. Our estimations are actually that we're scraping around 350 million posts a day, which is about 15 million posts an hour, guys. So this is a formidable vehicle that we've now gotten off the ground, and we're very confident in the incentive mechanism that underpins it. It took us a long time to make sure it was watertight, but now we're really ready to turn the gas up. So it's a real vehicle that we've got there. Protein folding, productivity we've been really thinking about in terms of the number of proteins that we're really able to cycle through and the quality of those simulations. Right now we use a gold standard simulator so that we can basically trust all of the simulation outputs. And we've coupled that with an increasingly competitive competition where the number of proteins that a miner can fold becomes sort of the deciding factor as to whether it can live or die on the subnet. Also, last benchmark one for me is Subnet 37, which is the fine-tuning subnet. Learned a lot from Noosa's Subnet 6 back in the day. Well, I think we've ironed out a lot of the kinks in their design. And so we've been actually training models on that for the last few months, and things are going really well. One thing that we've started to actually make use of is the data generated by Subnet 1 is now feeding into the Subnet 37 competition. Our multiple choice question, which is like our own Bittensor made benchmark, miners on Subnet 37 are actually performing really well on this as well, actually quite close to how Subnet 1 miners are performing on it. So we're really delighted about that too. So I'll jump ahead. Can you get me to the next slide? There we go. So I guess I've talked at a high level about sort of the numerical results that we've been getting. There's also a lot of features that we're really excited to start releasing in the coming weeks. The ones highlighted in purple I'll talk about today, but you can see that there's more than I have time for. So on Subnet 9, largely inspired by, I guess, developments in distributed trading that we've been seeing around us in the previous weeks and months, we've decided to undertake some pretty ambitious R&D efforts towards imagining what distributed trading could look like in Bittensor. We codenamed this Project Aladdin. We've worked with the guys at Manifold. We've also worked with Jake himself, Mr. Const, who has been helping us think about what a subnet design would look like that would support distributed trading at scale. We've been running lots of experiments, which I'll show you on the next slide, which indicate that this is closer than anyone could have imagined for Bittensor to be able to just absorb those innovations in the state of the art and actually start building subnets and tools on top of that. Also, Subnet 13, we're about ready to release our MVP product, which we call Gravity. Will's going to talk a little bit more about that in a minute. Gravity is basically giving the validators the ability to decide what data is mined, which is a direct path for them to create revenue and of course, monetize their bandwidth on the network. So it feels like a really natural extension of what Subnet 13 is already very strong at. We know that it can collect a huge amount of data very quickly, and now it's a matter of making sure that data fits the needs of people that want to come to Bittensor to drive the machine, so to speak. One more of our recent features or innovations is what we call Taufold, which is what I would call sort of the precursor to our fully fledged protein folding product. So Taufold right now allows people to see in much more detail the database of proteins that are being created in real time with analysis of the relative results, both through the lens of a mining competition, but of course also a research computer. So you can sort of get those two complementary viewpoints when analyzing what's happening in our subnet right now. So we have a slide for all of these if we've got time. We've got more backup slides and days of the week as well. In terms of collaboration, something that we've always felt very strongly about, one that we've been talking a lot with right now is actually the guys at Manifold. We want to start training sort of niche bespoke models for their specific use case, which I think we should totally invite Kara to the stage at the end of here and let him tell us more about what he wants to do and how we might be able to work together on that. But basically, we think that it maps beautifully onto not just one of our subnets, but several of them so that we can actually support him through the whole pipeline of data acquisition to model training and fine tuning. So we'll spend a moment on that at the end. I guess last one from me before I pass to Will as well is, as I mentioned earlier, Subnet 1 is actually now feeding data into Subnet 37 in the form of a sort of a never-ending benchmarking task, which we found to be enormously useful and of course something that's inexhaustible, which allows us to not have to worry too much about miners overfitting on the data sets. You want to jump on there, Will?
I suppose, Shib, any questions about that? That was
I'm going light and fast, guys.
Well. He's,
I'm charged up.
Yeah, I'm like, I have not had to pay attention this hard in a long time. No, I'm kidding. No, I think it looks. I know. I was just gonna say, I have a few questions. I can queue up to the end. But the one most pertinent one is for Subnet 13. So you said you guys you're building a boatload of data. Are you looking to publish that anywhere? For example, for like researchers to kind of play with, kind of like, hey guys, look what we built. You know, come build your model on it. We built some Bittensor, by the way, et cetera, that sort of thing.
So I have two answers to that. I guess, first of all, the original subnet design was one where the validators were kind of the gatekeepers. The miners store the data. The validators ask for the data. Unfortunately, this design quickly led to bottlenecks and rate limiting issues, which was never really the ideal design. So we decided to screw the whole thing force the miners to upload every data they scraped in an appropriately dehydrated way. They have to upload everything to Hugging Face as open source data sets. So there's no longer the problem of access to the data. It's sort of open source by default, which is a much better position for us to take longer term. Lastly, really the superpower for Subnet 13 is the fact that it's just a matter of whatever you set a high reward on, almost like a bounty program. Whichever data labels you set a high bounty on, the miners will go after that preferentially. And this is really the design of Gravity. Do you want to jump on that?
Yeah, I suppose that this links into one of the things we've been thinking about quite a lot on subnets, is that some subnets have like a primary purpose and then a secondary purpose. And with Data Universe, the original idea was let's create a web scale social media data set to help people train AI models. And it's been really good at that. It's now we believe the world's biggest open source data set. We have some work we're doing on improving the quality and completeness and, veracity of that data set. But, at the moment, it's very big and it's very cumbersome. What we wanted to do was actually say, there are people who sort of care about the data set from its mass properties quality, but there are also people who really care about getting fine-tuned fresh data. And I'm going to jump around in our slides. We'll go back to that one. We actually call that Gravity. Like as Stefan said, we're scraping 20 million rows of data an hour. That there are a lot of different services from Apify and Twitter have just launched their own service to sell their own data. But what's nice about Bittensor is it scrapes indiscriminately. So it scrapes Reddit, it scrapes Twitter. And what's also compelling about it is it scrapes in a way that all TAO holders can use. And we've been really interested by some of the ideas about this. But one of the big challenges in Bittensor has always been, how do you provide a commodity to validate to TAO holders? And we've been working hard to introduce this concept called dynamic desirability, which is basically, if you have 1/10 of the bandwidth, you get 1/10 of the data scraped through every epoch. So in this instance, every validator, Mr. Machine, for example, Mog, is going to be able to take, however, he's got like 14% of the data on the 14% of the bandwidth. He's going to be able to scrape 2.8 million tweets an hour. And this is suddenly really interesting for validators because we can create quite clear and simple business cases and product builds off this. And this is very much a new organic type of subnet, we think. So we've tested this. We have it in MVP. It's working. We've started to do a lot of work on actually what we need to do to get this into production. So we're working with the guys at Sports Tensor who are keen to use this as a fresh data source. The Paladin guys reached out to us the other day and said that we can use it, and OpenKaito have as well. So we have this group of users within Bittensor who are already excited about this. But we've also started to do some testing with validators who have their own customers and otherwise. And I guess this isn't necessarily just a pretty landing page. We've been doing a lot of work on product design in the background, a lot of research on more data sets and otherwise. And we're going to start sort of testing this in anger in the next few weeks. So particularly for any users or TAO holders or validators who have, I guess, interesting use cases for scraping data at maybe subnets or otherwise, we're obviously in this experimental stage able to perhaps be a little bit discounted than charging people full price. We think there's something really compelling here. But one thing that's really nice about data scraping is it's a really good use case for collaborative work. And what I mean by that is, say you want to scrape all of the information about Kamala Harris. Now, one validator can set tags on that and scrape for that. If another user or another validator is also asking to scrape that data, there's immediate opportunities for sharing of that information and cost efficiencies. So one of the things we're looking at in a future state is dynamic pricing. So in this state, if you're the only person searching for information on Kamala Harris, it might cost you 30 cents for 1,000 tweets. If there's 10 of you, it might cost you 3 cents, which immediately starts to talk to why Bittensor is super powerful as a community and how we're actually going to get some of the effects that are a bit unique about the network. So we're really excited about this. Some of these ideas are sort of early stage, but super keen to hear from teams or others who are keen to, I guess, play with this and help us develop it. So it's very much a sort of agile project development process. Our head of product design has been working night and day to get some of this done, but we're excited to be able to show a little bit more of this in the future. Yes, Uber for information, literally surge pricing for data is kind of how we thought about it. So
right.
that's exactly what we've been thinking of, which is super cool.
Should we do folding?
Yeah, do you want to do folding?
Yeah, great. So I talked about this really briefly earlier in the presentation. This is going to be the basis of our sort of MVP product. What you can see are a combination of sort of productivity metrics, and you can double click and zoom into any given protein that is currently being folded in real time. Sort of the active miners column, I'm not sure if you can see my cursor, but you can think of this as like the achievements to the players that are currently in that arena. So this is kind of like a mass multiplayer online game taking place in the protein folding realm. It's pretty cool. What this is also going to allow people to do is go deeper and actually start downloading these very large protein databases that we're starting to generate at this point as we're organizing all of our infrastructure in the background. The next step for this product is really we're going to enable very similar to through the sort of the organic query handling mechanism that drives Gravity. We're going to enable real users to submit protein folding requests as jobs into this network where they'll be handled and scored using organics. So we have a really clear path to making this sort of a fully interactive and directable subnet platform.
And I think that this point's really important, that there's a couple ideas we've worked on really hard in one subnet that suddenly become relevant for others, and we think for a lot of the other subnet owners on the call are going to be irrelevant. Things like a lot of the work we've been doing on epsilon and dynamic epsilon are actually super relevant in protein folding, and dynamic desirability is super relevant in protein folding. Everything's relevant in protein folding, guys. Basically, you can see the hype beast in the channel, but like you start to see these other pieces, and you'll see some of the utilities libraries we've been building on subnet 9 and 37, building out this composable toolkit of stuff you need to build subnets, and we see ourselves doing more and more of that. So you're going to see more of our stuff coming out in that form where other people can pick it up as building blocks to accelerate the Bittensor in its whole state.
The protein folding subnet design, it shares about 95% of its DNA with subnet 9 and 37. Actually, there's a surprising amount of commonality. Even decaying epsilon, which is something we came up with in subnet 9 recently, is actually already embedded in the subnet a week after we released it in subnet 9. It's pretty crazy.
Yeah, so this is on our staging environment, guys. We're running on it. There's a really big refactor running on subnet 25 that I think, Brian and our team, everybody in the folding crew are really excited about. And that goes, I think it actually went live on Thursday, didn't it?
Yeah.
Oh, sick. There you go. I should know more about my own release plans. But there you go. So folding is getting a big upgrade next week, and we'll be launching TauFold when the final bugs and fixes are done sometime next week, hopefully. And I guess the final thing we really want to, there's this and then one little more thing at the end is the work we've been doing on I guess, pushing the state of the art in decentralized training. And Steph, I'll hand back over to you on this.
Yeah, I guess, first of all, I don't think Const has slept since learning about the latest developments in the state of the art. So this has been largely led by him not sleeping. But we've also been trying to keep up, and we've been working with him and trying to work out, I guess, some of the kinks in the design of how does one do decentralized training at the sort of scale that's necessary to train meaningfully large models sufficiently fast to actually make this competitive out there in the industry. So we've been really busy at Macrocosmos for the last, I think it's about 10 days. It's not been much time. We've been training models up to about 1 billion, which is equivalent to other demonstrated methods that have been, I guess, making some noise recently. We've been really happy to find that we're already starting to find that we've got baseline approaches that are sort of, before Shib interrupts me and says, what the hell does this mean? Your baseline approach is basically, you don't try and do the fancy stuff by distributing it or any of that. You just do all of it in one big cluster, because of course that's probably the best result you would get if all things were equal. So we run our experiments in that scenario. Then what we do is we slowly but surely pull all of the parts in the cluster and throw them to different corners of the world and see how resilient our system is when more and more of the nodes in the system are actually separate and have to communicate via some lossy and imperfect protocol. We've gone pretty deep into this, and we've already been able to get some pretty good results that we're proud of. We've gone over 100x compression of the data transferred. The material meaning of that result is without any data compression, in order for miners to be able to meaningfully train a model in a decentralized way, they'd have to share a ludicrous amount of data really, really often. And you'd basically spend all of your time waiting for data to upload and download. So they actually wouldn't get to do much training. They'd just be waiting for transfer. So by compressing the amount of data that you're passing over the wire, you're basically able to spend a lot less time waiting and more time training. So of course, the larger the compression, the better news it is for everyone on the network and the more productive everyone can be together. So we've got some pretty strong signals that we're on the right path. A lot of this is just really careful design of the, I guess, the compression algorithm and the way that everyone synchronizes once in a while so that the miners do still end up collaborating on the same underlying model. We've got pretty strong signs that we are going to find convergence in our methods all the way up to sort of 800x and beyond. The plot on the right basically shows, I believe let me get this right. The blue line is everything all in one data center. The orange line is 100x compression, basically dispersed across different machines. And then the other two curves are increasing amounts of compression. Pink is 500 and green is 850x. And you can see how it causes a little bit of perhaps a latency in reaching that loss, but eventually we still reach the same losses, which means that we're still producing models of the same quality. And we're confident that we can just make this get faster and faster as we reduce the friction in the design. So lots of ongoing experiments. I would say a combination of Const and Caro have demonstrated that there are subnet designs that actually enable this to happen as well. So there's actually, there's subnets on testnet which are demonstrating this method is viable. We are making sure that we fully understand the system before we try and do anything as bold as to register anything. We're drowning in subnets at some point. So we don't want to get a little too opportunistic, but more than anything, we just want to make sure that Bittensor sort of plants a flag and says, anything you can do out there, we can do internally, and we can do it fast. And I think we've done a really solid job of that in the last couple of weeks. With the next couple of months, I'm absolutely confident that we're going to be at the frontier. So I'm happy to leave the Project Aladdin slide there, and we'll move on to the last topic.
Does Jake want to chime in there? I saw the little dog appear in the top right corner.
I did it. I already implemented this. The subnets can be launched today. I actually made it fucking work today. It's amazing.
Dude.
I wrote the whole subnet this morning. Proper loss convergence. No loss. This was amazing. We were super close the other day. We were doing the top K. We were producing masks and then training the masks and then passing the masks, but they were training the whole model and then passing the masks, which was kind of the inverse. But yeah, so I implemented it today, this morning, and it's fucking working, and it's really fucking fast. And I'm training over 6 H100s right now. Loss curve looks beautiful, requires no master state. It's amazing. It's fully decentralized. We're using intermediate S3 buckets, so it's like completely... it's probably the fastest decentralized training mechanism in the world. I could easily train a 7 billion parameter model tonight. We could do 70 billion. We actually could train 100 billion parameter model with this method, which is unbelievable. And so I'm going to be unable to finish it for personal reasons, but I have the code. You should take a look at it. It's super clean. It's super fast. And
is it the code that Kara posted? The Kant repository?
It's definitely work in progress. Don't break anything. The validation system is actually really obvious in what we're in the design. The miners basically just have to train on a page as quickly as they can. We can synchronize states really quickly. We're using intermediate S3 buckets as like this, the peer-to-peer method, which just makes things blazingly fast. Like nobody thinks like that when they're building decentralized training mechanisms. They're all like, oh, let's use peer-to-peer, Cadmelia. And I'm like, no, we have incentivization on our team. We can get miners, fuck the miners. We can make the miners pay for S3 buckets. No, just kidding. But also validators. And so like we can do these things like really, 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 really fast. We can combine H100s from across the globe. Gosh, it took what, 3 weeks for us to discover this mechanism, and now we actually have it in play. So that's amazing. It happened today.
Guys, we wrote the slides yesterday and we hadn't quite got there. And Jake's just not fucking slept, which is why he's the hero.
But maybe more profoundly than that, guys, just wait a beat. Jake just announced on a call that he basically made AI history. That's just the heartbeat of Bittensor. This should be his novelty search, guys. That's absolutely insane. Massive project, unreal.
Look at that.
Do you want to just wrap this up and make this your night now? I mean, you've just flexed on us, dude.
Yeah, I've been having fun all morning. Look at that step loss in the chat. It's so beautiful. It's so clean. Mwah. Oh, it's so clean.
Yeah, you screen, baby.
Yeah. And so like, okay, all right, it's look, RWH, it's been training for an hour, so fuck you.
Constable, what kind of hardware are you training it on?
I'm running on Rob's machines. Rob has very kindly leased me H100 boxes. So what
I love how we did this whole thing to try rug another research lab, and you've rugged us mid-call. Rug tensor.
I re-rug them. I mean, we were so close. So like,
got rugged. Exactly.
Like basically the way that distro works by, basically you're merging the models, but you merge certain states. You like basically you take a random sample of the parameters and then you have all the miners merge them, right? So you can compress as much as you want. So you can be like, okay, we'll take, these parameters, like one every 300, 1,000 parameter, and then all the miners share those parameters, and they basically they merge them, they average them, and then apply them to the model. And this is what keeps the models in the same like state bounding box, right? It keeps them close enough together that they can train together. It's a really brilliant idea. And we were basically doing something very similar, right? If you guys remember, what we were doing was taking a mask of the model, training the mask of the model, and then sharing the deltas, which is actually just the inverse of what they were doing, but theirs is actually better. I would definitely say it's much better. The really nice thing is how easy this is to build on Bittensor. Like we have such an advantage because we have like a whole toolkit for, oh, hey, what's the current block? Who's online? What are their UIDs? What are their hotkeys? We know how to work in these synchronous settings where everyone can see the same state, right? You need a blockchain to make this stuff work in decentralized training, because what if you want to produce a mask by taking the hash of the current block, right? Well, if you're trying to use Cadmelia, that doesn't exist, but a blockchain has that. It's super easy. You just go subtensor.block, put that into your NumPy random generator, and boom, everyone is on the same mask. Everyone has the same block height. Everyone knows that they can work at the same time because we have blocks in the chain. We all know who's online, right? We all know everyone's hotkeys. We can sign messages, and then we just have a validation system and an incentivization mechanism that works on top of that perfectly 100% of the time. Like we know how to do that. So, like I think that's one of the most amazing things. I'm having a lot of fun building with Bittensor's toolkits right now, because just seeing how basically everything fits underneath our API. Okay, let's imagine we didn't have Bittensor and we wanted to build an incentivization mechanism around something like distro. Fuck, right? Well, you just end up building Bittensor because you need to have state, you need to have miners, you need to have incentives, you need to have weights, you need to have consensus on those weights. All of that stuff just works right out of the box with what we're built. So I was able to build a complete replica of distro under an incentive mechanism in a distributed peer-to-peer network by 4 p.m. today. Right? And that's
my favorite thing in the world is I was gonna say my favorite thing in the world is telling people just how easy it is to ingest any technology using Bittensor and just build an incentive mechanism for it and set it up. And you've just proved that yet again today. So well done. Beautiful.
It just inhales the state of the art in open source, guys. It's the secret
That's all we
power.
do. We inhale it and we shit out. That's what we do.
Almost like it's got a gravitational effect working on it. Hey, not just sliding some marketing in there. Amazing stuff, Jake.
Bittensor is so fat, got its own gravity.
Yeah.
Look,
I mean, there's a lot to do here. Like, it's one thing to have the design and go like, okay, this could be put into play, and then you realize, okay, well, those fucking miners are going to destroy it. So we need to be really, really careful about the way in which we design the incentives. But working with incentives is the best way to describe a problem in a distributed setting, because it goes, no matter what you build, you're gonna have to ask the question, like, okay, what will an adversary do? And
Right.
we ask the question, what is like the local minima of an incentivized participant, and how do we make the local minima for an incentivized participant? How do we make it? How do we make the local minima isomorphic to the problem that we're trying to solve, right? Like matching game theoretic equilibrium with machine learning equilibrium was where Bittensor really started. So like it fits perfectly, right? Okay, hey, we want them to produce updates that have that are incredibly that decrease the loss the most, and so we can actually write that in Bittensor as an incentive design. Right? Like we have the technology. Super cool. Anyways, yeah, I'm really excited. Everyone's looking at my code now.
Stars going up, dude.
Yeah. So I may have jumped the gun. Like maybe it's not completely finished, but yeah, guys, watch this space.
Too late for that, man. JJ's already tweeted it. It's out there now. There's no going back.
Cool.
That's gonna piss off a lot of people. It's gonna be great.
We've already trained the largest decentralized machine learning model in the world, right? And just nobody knows about it, right? Like TensorPlex, Colden, like they train 7 million parameter models in underneath an incentive mechanism. Like nobody knows that. Everyone's still like, oh wow, the best
on the 14B right now.
You know what I mean? Like, yeah, this just fits our domain so well. And we can, so we can build it. Let's do it.
So
I mean, should we launch on main like right now?
Right now.
Just war room. We've got like 70 people. Let's just war room the whole lot.
Don't leave. No one sleeps.
Where's Kara? We need him to live code this.
Go and get a coffee, guys. It's going to be a long night.
Cool. Yeah. Anyways, I'm going to go back to that.
Back to the cave with you, boy.
Look, guys, we have one more thing we wanna talk about, and we moved to it, and then we got caught on distro again. But one of the things I get asked a lot by people is like, oh, why wouldn't you just like go and build your own Bittensor thing? And that's a stupid fucking question, because the nice thing about Bittensor is there's this incredible amount of really brilliant subnets that you can pull together to build something that we think is going to be more than just the parts. And, one of the things we tried to focus on today is a lot of people have been sort of paving the way on one-to-one product subnets. This subnet does this product. We've started to do a lot more on subnet connectivity. We showed that a few slides ago, working with other subnets. But we're working on something in the background that we sort of codenamed Constellation. And that's this bringing together of a lot of our subnets, at least 4, maybe we'll throw protein folding in there just for vibes. But also some of the other commodities we see on Bittensor as being super valuable to create this system that is broadly going to be a large-scale niche AI training platform. And Constellation, we did not plan that, and he is not involved in this.
Oh my god!
But look, we're going to be talking more about that in detail next time we come on Novelty Search, probably, because there's a long way to go on that. But I'd love it if we could pull Caro up, because one of the test use cases we're doing for this is Caro wants to train a model that works on a robot and like goes and murders people or something. So we've been working with the Manifold guys on everything from the data set acquisition, the model training parameters, the fine-tuning needs, any agentic augmentation, and work out how the hell would we actually build this whole thing end-to-end in Bittensor with subnets. So Mr. Rob, I'll hand over to you to talk a little bit about that. So we've been scheming on this in the background.
No, yeah. So I appreciate you the shout out, by the way. But no, so we've been doing a lot of just research recently around Omni models. I think that there's been a lot of like really promising progress with like the sort of like 3-stage fine tuning process. So you take like a already existing pre-trained LLM and then you smack on like a layer here, a layer there. You do different alignments. So like you align it to the modality you're trying to do, and then, you know, so on and so forth. Right. And that's produced some really good any-to-any models. And I think that a lot of the shortcomings of these types of models where they do these 3-stage fine tunes is that because it's not it's not pre-trained from scratch to do this sort of any-to-any input output, the results are always going to be sort of worse than if it were just pre-trained from scratch. And so obviously doing a pre-training run is very expensive. It's very similar to rocketry, where, you know, you have basically a budget of 2 weeks, and, you know, like, okay, like if this doesn't go right, then we've just kind of like bankrupted the company. And so that's when we started like thinking about talking to y'all about doing this on Subnet 9 as a competition, where we could pre-train it in a decentralized fashion, and it, you know, we can iteratively improve the model over time, especially with the new feature set that y'all have added to Subnet 9 recently. So yeah, really the what's powerful about this is having a foundational model that can do any-to-any input output pre-trained, and then you can fine tune on top of that so that like you can do torque actuation outputs from the latent space, and then you can use that to incorporate into quadrupeds, bipeds, Roombas, like kind of like drones. You can incorporate it into anything. I'm really interested in embodied AI going into the future, and so yeah, it's been really cool to be able to work on that with y'all.
Yeah, so thanks, Rob, and it's been great working with you guys. So we're looking forward to helping Rob build Terminator, and you know, people who are saying that Bittensor is Skynet will then be right. So, you know, that's the mission, guys. World domination. But look, all joking aside, we have another couple businesses we're working with on this. A small UK startup called Hopper, and potentially a larger sort of FTSE 100 company we're trying to get an innovation pilot with. So the intention of this is we develop this in flight with a few potential users to work out how we get this thing to really work in anger. So lots to do, lots of excitement. Thanks for having us, everyone. But I guess the final point I sort of want to leave there is there's been a lot of talk in Bittensor about how do we make the first $20,000 of revenue, and we're trying to work out how we make the first $1 billion.
Whoa.
Wow, what an ending. Any questions from the audience? Leaving it open.
Sorry, guys, you know I have to do a mic drop.
I didn't hear any mics dropping, but nice.
I threw our CFO on the floor.
While we wait for questions from the audience, I would be delighted to share one of our backup slides. It's not KPIs or benchmarks, guys.
Stop the benchmark.
No, it's not benchmarks. This is one from our very own CEO at Macrocosmos, Will Squires, will be at the annual Labour Party conference this weekend, lobbying for AI in the UK, including Bittensor.
Yeah, somehow they've let me be on the panel with the Minister for AI, guys. So I am going to be pushing T. I am going to be pushing T. But in a serious manner, to help British small medium enterprises grow responsibly.
You can hear the screenshots. Twitter is already flaming that picture.
All right, we've got Yetzira on stage. Go ahead.
Yeah, I'm an aspiring entrepreneur, and I was wondering, because you mentioned drones, I just came in towards the end of your guys' discussion. I'm trying to start my own decentralized app for drone services, and I want to use Tau, and I've always wanted to be a part of your guys' network. I'm just dealing with like no capital. Like I'm very poor, I guess you can say, but I am designing my own app. I'm building out my own app. I'm coding all of it. And I'm wondering what you guys would recommend for someone like me, or if I'm trying to develop on the SUI network side of things, but for the cost reason. But I'm wondering if you guys would maybe recommend something else for me, or if maybe I should transition to Tau in some sort of way. I just don't know how.
Yeah, I was going to say, first, welcome to the community. Good to see you here.
Thank you.
I think that it requires a bit of finessing, just because, obviously Tau is a very different infrastructure to SUI. And we would definitely need to probably take this offline to kind of chat a little bit more about what you're trying to build exactly, because it's going to boil down to how you design your incentive mechanism, how you design your validation, how you're going to approach your entire business model, really. And so Bittensor is sort of one of those few ecosystems where, the business model that you have is very, very closely tied to the subnet and your infrastructure as effectively your pipelining, the infrastructure of your code specifically. So yeah, my recommendation is reach out to me or to Const offline. We're more than happy to sit down with you and understand what it is you're trying to build and what your needs are, and see if Tau is actually a good match for that. And if so, then we'll be more than happy to direct you to the right people.
The same for me, Yatsura. And I think the only thing I'd add is a lot of people come to Bittensor and think the only thing to do is to build a subnet. I think we actually need to start moving into the wave of people building on top of Bittensor, on top of all these commodities, on top of all these capabilities that are in the network. So, Mog has been a big proponent of this. I think he's sleeping right now. But I think increasingly it's going to be coming to Bittensor to access some of the best commodities to build your app and capability. And that's really exciting.
Agreed.
Thank you so much, guys. I appreciate your input. And Fox and Constant, I will be reaching out to you shortly.
Awesome. Thanks, Yatsura. Any other questions for the Macrocosmos team?
Does my mic work? Hello, friends. Yeah, so I mostly, I mentioned it in the chat already, and it's probably mostly a const question, but when I was first getting my head wrapped around distro, or trying to as best I can, they were going over that the majority of the work that they had done was re-rigging the AtomW optimizer, which is just sort of one component of, obviously model training. And then I'm looking through this here and seeing okay, validation, the masks, if I am the validators are trying to evaluate the best contribution, and whatever does then actually goes into the layer is sort of what I'm gathering from my 2 minutes of looking at the code. But anyway,
not enough. Not enough time. You
enough?
need to spend more time.
Yeah, probably. Yeah. But mostly my thought is... sorry, go ahead.
We can also just talk about it on the stage if you want to ask questions.
Yeah, well, so I guess my I think maybe a stage relevant question is so in terms of how you designed this sort of distributed implementation, what would you say are sort of the main ways you tried to address some of the traditional problems latency and lossiness or gradient averaging and stuff like that, sort of the classic distributed problems? What is this implementation, what improvement vector is this mostly angled at? And then from there, my extension is okay, so what other improvement vectors can we go grab from wherever we can find them and throw them on this thing and then make the bestest, mostest thing in the world or whatever?
Right. Well, I mean, okay, so first of all, I actually believe that in order to do distributed decentralized training the best, we should actually be writing everything from scratch. Everything in machine learning has basically been built for in-house, non-incentivized, homogeneous machines, non-adversarial designs.
Definitely, yeah. Same right? Machines in the same place, yeah.
Yeah, exactly. So we actually need to approach the problem differently and build it up from the ground, and to fit into a decentralized environment, rather than being built for the last 25 years of deep learning, which has been primarily on NV-linked GPUs in the same cluster, right? So where was I? So you were asking questions about like what are we doing to jig the system or like change the system. So one thing that we can take away from almost every single design on Bittensor is that when you are designing an incentive mechanism, the more that you can put underneath of the incentive distribution, the better. Like the more that you can be like, oh, okay, well, if they can do it faster, then they get paid more. Rather than how can I make it faster? Do you see what I'm saying? Right?
I do, yeah.
So like however you build the incentives into a design like this, and I will just say like that it's not fully built. Like I would just say I've put in like mostly the distro training optimizer that allows us to build the incentives on top of it. But the way that we want to build it is so that like if you have a low bandwidth machine, you don't make as much money, right? Or if you don't have a fast machine, you don't make as much money. Or if you produce bad gradients, you don't make as much money. And the answer to all those questions usually is best framed by directly measuring the thing that you want, which is like, hey, did your gradient decrease the loss, right? Like Subnet 9 is very explicit in that. It's like, give me a model that decreases the loss as quickly as you can. That is Subnet 9. In this decentralized environment, I think it's going to be more like, produce me a delta of your model in the specified amount of time that improves the loss on a subsample of the data set that you were supposed to be training on, and be within some sort of bounding box. Like a lot of Bittensor incentive mechanisms work really well if there's sort of a binary loss, like don't go over this threshold, but try to maximize this thing. So I think that's probably how it will be designed. Like in distro, to give you just some like, I took a look at their slide and I could see what they're doing because we were very close to doing it before.
Oh,
but
the slide from the con thing that they had recently. Okay, yeah.
The general idea, it's actually very it's very elegant. It's very simple, and that's what makes it work. And like just basically the idea is that imagine that me and you are training over the wire. Instead of having to share gradients, we just take a subsample of our model. Like, hey, take the 10th weight and the 30th weight and the 77th weight, and we'll both share those parameters n by n, right? So everybody will share those same parameters, and we'll average them and put them back into the state of the model. And assuming that we do that often enough, over time, we can guarantee that we're actually still training the same state, which is really, really, really good for
interesting.
Because you want to know what the global state is. And in a decentralized system, you don't want to have a head, right? You don't have a leader in a decentralized system. So this is much more adaptive. It's like, hey, let's just share aspects of our state periodically. And what that turns out to be is actually a model merging. It's just like model merging aspects of the model every step. And I think you could probably derive exactly the learning rules of standard machine learning, except just framing them as distances between models. Like my guess is that it pops directly out of like standard gradient descent, and that's what you could see on the slide. So when I saw that slide this morning, it was like, oh my God, we're so close, because what we've been doing up until that point was having the distributed miners train a mask of their model. So like pick like 10% of the weights and then learn on those 10% of the weights and then share the delta between them and the master.
That rather than like getting the gradient. Yeah, rather than getting the gradient descent, it's sort of like it's like mask averaging kind of, or like a distributed sort of Frankenmerge kind of thing is how my brain's like trying to digest it.
Yeah, It's a good idea. Yeah, exactly. And if you listen to his talk, I think it was Block. His name is Block. Seems like a really brilliant guy. He's like, oh yeah, well, basically we took the idea that you want to be close, but not necessarily fully close to all of your neighbors. Like you don't have to have exactly the same training state. You can have a partial training state. So anyways, with that in mind, so like that's one thing is just using that mechanism and the way that they designed it. They don't require a new optimizer. They're trying to build distro into something called Nanotron, which is their distributed training distributed training optimizer. And they're not actually building a new optimization algorithm like Atom. They're just using Atom and then sharing these deltas between the peers. So now, if you wanted to build that in the wild, you'd have to have some like stateful understanding of like where all the peers are. For instance, you want to know a block number, right? Because hey, if we're all going to merge the same parameters, we need to know which parameters we're merging. So that requires a whole gossiping thing to happen. Or you can just, everyone can look at the current block on the chain and go, oh, wow, great. Well, the current block on the chain is X. So we can seed our numpy random by that block hash, and then we can use that to produce the mask, and then everyone just shares everything, and you don't even have to send the indices. So that's what's fucking amazing, right? Because the indices are U64. So you can, not only can you subsample the model like at 300x, you can subsample the model, not send the indices of the top K, and also compress the floating points down to like bit 8. So you can get like 2,000-3,000x compression. It's wild, right? Like I'm doing my current training run is just doing 300x compression, but it's proper 300x compression. We're sharing the weights of a 1.2 billion per hour model at 10 megs. It's so small, right? And I think that they've said that you can go up to 1,000 and beyond. So this is why I'm thinking like, okay, we can go to 100 billion.
If it's like block height or epoch lengths, because like Mina with recursive ZK proofs has like a 33 kilobyte entire blockchain. So it like, there's all, if the concept of sort of using the block state as like the clock rather than whatever like a single individual machine training is really interesting actually.
And the final thing was I've actually been working on this for some time, and I've always believed that the way to make this really fucking fast is to not require the upload speed of the individual miners, because who knows what the upload speed of the miner. That's always the bottleneck. So if you look in this design, what we're using is we're
really
forcing
cool,
all validators
actually,
miners to use an S3 bucket, and so they just push these masks every block. They're just pushing masks that they train the model to push masks that happens really fast to this S3 bucket, and everybody can peer super fast because the upload and download speed of S3 buckets is effectively unbounded. AWS just charges you more. Do you see what I'm saying? Like, so you can get like 100 gigabit upload and download speeds on these S3 buckets from around the world, and they'll just auto scale it for you. So that means that we can work with like thousands and thousands and thousands of peers, all peering off S3, paying costs because we have incentivization on our side. And we don't have to work on 1 billion, 2 billion, 7 billion, 14 billion. We can start to work on, in this design, 100 billion per hour models. Like this makes, and the bottleneck actually becomes the compute of the edge nodes, right? Can you do the distributed data parallel, et cetera, et cetera? But yeah, so.
Yes, thank you for that information. Excellent. No, there's lots of things to think about from here, I think. But yeah, I'm definitely going to dig into that repo. Anyway, I appreciate it. Maybe I'll probably end up DMing you about it later. But yeah, thank you for the explanation. That's a few things that I didn't get there that now sort of like are making sense. And it's like, oh, that's actually exactly what you should probably do here with the current mechanisms that you have at your disposal. So yeah, very cool.
Yeah.
Also, nice
Yeah.
job, Macrocosm. Sorry, it turned into the distro show, but all of this in tandem is very, very cool. So yeah,
Cool, man.
Thanks a lot, man. And Jake,
Thank
thanks
you.
for the casual masterclass there on distributed learning.
I think about it a lot. when they launched their paper, like credit to news research, honestly. Like seriously credit. Like unbelievable. It got us thinking like, oh my God, this was possible. And yeah, as soon as they launched their paper, I was like, I couldn't sleep. I mean, they didn't even launch their
For 72 hours after they dropped that, you just insisted that I pick up the calls from you, and you just got more and more delirious and less intelligible, but the ideas were definitely getting better and better, and you've solved it.
I think so. We'll see. The next thing is, so we can move fast with this design for the miners. They sync state that doesn't require master. It's really amazing. The question is, how do you frame the incentives properly for miners on this network? So everyone's producing these masks. We know what these masks are going to be because we have block heights and we can use NumPy randomness and stuff like that. And we can also enforce that the miners are working on specific subsets of the data set, which is useful. And you can also use block height for that kind of thing, which is really cool. And like one thing we can do is go, hey, like we're just going to exclude masks that are like outside of some sort of bounding box, to stop like poisoning, et cetera, et cetera. But then like the final question is, people are sharing these masks of their model that they're training, and we know which data set they've been training the models on that produced the mask that they're sharing. And we could get really fancy mathematically about how we measure the performance of the training run behind the miner that produced that mask. And where this clicks is if you can design it in such a way that if somebody puts way more compute on their machine, they make way more money. And if we can get that right, then we can go to, 10,000 H100s. Now, even better is if you can make it so that if they can think intelligently about how they produce their deltas and how they train, and if they can train more intelligently than the next guy, and push the loss down consistently and always in a guaranteed way, that's more like Subnet 9. And that's when we don't need 10,000 H100s, right? Like one of the problems with Subnet 9 is like, oh, we can't afford a cluster of, 10,000, 20,000 H100s, but it doesn't really matter because we have people like Coldint and TensorPlex that are actually better than the best in the world at these companies. And they're doing it for cheaper, right? Producing models that cost $50 million, they're making them for 50 grand. But if we can bring that same thing into the decentralized, like the proper decentralized training regimes, I think sky's the limit. Like we can really truly, quite literally train the largest and best machine learning models in the world in Bittensor, and that's like the holy grail. But like I said, it comes down to the how directed we make that validation system. So yeah, looking forward to hearing people's thoughts. Like I've got a lot of good advice from Coldint and syncing ship from TensorPlex, and I'd like to hear from those guys later on. Cool. Well, yeah.
Awesome. This has been a fantastic discussion. I mean, we're really seeing the future right here in front of us, and kind of in line with that future. I think a lot of us here are here to kick off the new RAW games, which is a preview of kind of what the future of the Bittensor ecosystem will look like in terms of like how subnets will work on a grander scale. And so we can have this kind of double preview where we see, the accomplishments of what Bittensor can provide as a platform for advancing AI, and we get to see a little bit about what that can look like in terms of subnet dynamics. So if you guys are ready, I think we're ready to kick off the new RAW chain. So we're going to have a 100 tau reward for this game. It'll be a week long, just like last time. And we've got some additional players this time around. Everyone who was in the games previously, we're going to use your cold key that you had given us already, unless you gave us a new one, in which case we'll use the updated one. But then we have some new players as well, so it should be an even more competitive game this time, and it'll be a good way to kind of get an idea of what these trading dynamics could look like with DTAU and the future of Bittensor. So if you guys are ready, our very own Prop Physics is gonna start up the chain. Yeah, let's get started. So Prop, fire away. All right, we're booting.
Boot. Let's go. Route.
Go immediately stake into Subnet too.
Okay, we have a question on testnet or custom. RAW actually has its own endpoint. So what you want to do is actually install Bittensor with the RAW branch. So you want to git checkout RAW within the directory for Bittensor, and just go ahead and pip install that version, and then you will have the endpoint. It'll be preloaded as the default. All right, we already have a handful of subnets being created. Like we have 5 subnets. Fantastic. Oh, it looks like we have Sai in the call with us. He's the person who won last time. He totally dominated the last RAW games. We'll see how well he does this time.
Oh no, everyone's spamming it right now. Wait, did I get nerfed again?
Maybe.
I love how this is just like a bunch of dudes playing a video game now.
I know. I can start streaming. I have to switch computers, but it's like professional Excel.
Really makes me want to play a LAN party again.
Yeah, it's like Star Citizen.
Are we just
Not
playing
Star Citizen,
multiplayer Excel right now?
It's like Excel. Like if you, especially everyone's got to install the watch command. Watch btcli st list. Okay, I have begun allocating. I am capital allocating.
But are you registering?
I don't think I am. I've been trying, but okay. Do you know the command off the top of your head to get the number of subnets?
All right, guys. Well, the games are in full swing. Some of us are getting rate limited, but otherwise, good luck, and may the odds be ever in your favor.
Your favor. Amen.
All right. Thanks to the Macrocosmos team for the presentation. Thank you, Const, for your insanely cool update. And as always, thanks to the community. It has been very, very good seeing you guys again.
Thanks, everyone.
Cheers, guys.
Bittensor on
Jen.
Good night, guys.
Ciao, guys. Lots of love. Bye.